Okay, now this is just continuing from where I left off in the lesson. So when is the particle first at the origin? That would be when x is 0, substituting x is 0. We're trying to solve cos of 2t plus pi and 3 is negative a half. Now this is quadrants 2 and 3, and we know that, so it's quadrants 2 and 3 because cos is negative. So we say cos of what is a half, ignoring the negative because that's for the quadrants. We know that cos of 60 degrees is a half, or cos of pi and 3 is a half, so therefore the acute angle is pi and 3. So now we need quadrants 2 and 3. Quadrant 2 is 180 minus, which is pi minus pi on 3, and quadrant 3 is pi plus pi on 3. So therefore that is, well, we've got 1 minus a third is 2/3. 2 pi and 3, and 1 plus a third is 1 1/3, which is 4 pi and 3. But that's what 2t plus pi and 3 is. So therefore 2t, I need to subtract pi on 3 from each of those, and I get pi on 3, and subtract pi on 3 from that, and I will just get 3 pi on 3, which is just pi. And if I divide by 2 now, I get time is pi on 12. No, sorry, pi on 6. That's a 6. 2, we get time is pi on 6 and pi on 2. So therefore, the particle is first at the origin, is first time at the origin when t equals pi on 6 seconds. Now, if we look at the diagram that we drew earlier, here, this is the origin here, and it's it's more than pi and 12, so that makes sense, because pi and 6 does lie between pi and 12 and pi and 3, even though this diagram is not drawn to scale very well. But that would make sense, that answer. Now, the next question is, so that was when is the particle first at the origin? The next question, part 3, is find the first time when the particle is at maximum displacement. Now that can be read from the graph as well, okay? Now if I put the graph that I drew earlier, we're expecting an answer. Remember, this is time negative pi and 6, this is time 0. So the first time when it's at maximum displacement, we're expecting the answer to be 5 pi and 6 seconds. But we're going to do it using trig to check. So I think the answer's time is 5 pi and 6. Let's have a look. So we know that the maximum displacement is x equals 6. Because earlier we looked at the extremities of motion. Earlier in the lesson today, extremities of motion were from -2 to 6, so therefore maximum displacement is x is 6. So we're going to substitute x is 6 into our equation for x. So 2 plus 4 cos 2t plus pi on 3 is equal to 6. So taking the 2 over and dividing by 4, we will get that cos 2t plus pi on 3, we'll get that it's 6 minus 2 over 4, which is 1. So we're trying to see cos of what equals 1. Well, just drawing a normal cos curve, we know that cos of 0 is 1, and we know that cos of 2 pi is also 1. So therefore 2t plus pi on 3 equals 0, or 2 pi. So subtracting pi on 3, we get 2t is negative pi on 3, and 2 minus a third is 1 2/3, which is 5 pi on 3. And dividing by 2, we get negative pi on 6 and 5 pi on 6. So therefore, the first time when the particle is at maximum displacement equals time is 5 pi on 6 seconds, as we saw in the diagram that I just showed you. Yes, this is because t must be greater than 0, and so therefore, so it's really important that you do put the 0 and the 2 pi here, because you know you need to do a full period. Otherwise, you're going to get just a negative pi and 3 as your answer, so you do need the 2 of those. Okay, so that was part 3. Now for part 4, find the first time when the particle is at its minimum displacement. Now, this will be minimum displacement is at x equals -2. Because when we looked at the extremities of motion before, and even looking at the graph, extremities of motion are between -2 and 6. Now I can actually, we're expecting the answer from our graph to be pi on 3 seconds. Okay, so let's see if that's what we get. Okay, so if you're very confident with how you've drawn your graph, then you can give those answers from there. Okay, so let's substitute x is -2. So we've got 2 plus 4 cos 2t plus pi on 3 equals -2. Now making, just rearranging this, we get -2 minus 2 over 4. So -2 minus 2 divided by 4 is -4 on 4, which is -1. So cos of what is -1? Well, it's cos of pi is -1. So therefore 2t plus pi on 3, so cos of what is -1? It's cos of pi according to this. So therefore 2t is pi minus pi on 3, so that's 1 minus a third is 2/3, so it's 2 pi on 3, and therefore t is 2 pi on 3 divided by 2 is 2 pi on 6, which is pi on 3 seconds. And if we look back on the page before, when x is -2, time is pi on 3 seconds, and that is the answer that we were expecting. So if you can do a good graph, it actually has, we only really needed to do one of these equations that we did. We could read this one from the graph, part 1. I think we could read the centre of motion, from the graph there as well. I think the only one that we couldn't read clearly from the graph was when is the particle first at the origin. That was the only one we couldn't read. The other ones, the maximum displacement, was actually easily read from the graph, and so was this last one, that was easily read from the graph. Okay, now that's the end of those examples. What I'm going to do now, I'm going to do a worded problem, and we're going to draw our graph from that. It's just an example from Cambridge. Okay, now it says, a weight hanging from the roof on an elastic string is moving in simple harmonic motion. So here's the roof, there's the string, and a weight is hanging off it. Okay, now that weight, because this is an elastic string, that will go up, down, and up. That weight, it'll move from there, down there, back up, etc. Okay, now the question says that it takes 4 seconds to move from the bottom of its motion, which is 15 centimeters above the floor. So here's the floor. Oops, you can't see that very well. So it takes 4 seconds to move from 15 centimeters above the floor. So this is 15 centimeters height to the top of its motion. So let's say it goes from there to there. Okay, here's the top of the motion. That's 55 centimeters above the floor. Okay, so that distance from there to there is 55 centimeters. That means that the particle actually moves from 15 to 55, which is 40. Okay, so the first question is, find where it is 3 seconds after rising through the centre of motion. Now before we do that, we're going to have to set up an equation. Okay, it'd be easier to draw it like this. Okay, so we know that the weight goes from, that's the top, the roof is up here somewhere, that's the roof. Okay, and it goes from 15 centimeters to 55 centimeters. So obviously 55 to 15 is 40 centimetres, so the centre of motion, this is the centre of motion where I've got the arrow, that would be at 35 centimetres above the ground. Now, instead of doing your scale lifted up, I mean, you don't have to. Now, there are two ways that I can draw this graph. I mean, I can draw it exactly as it is, and I will do that down here. So I can choose to draw it like this. Now, just watch what I'm doing. Don't actually draw it yet. But I can choose to have, let's say, 20, 40, 60. I can have the centre at 35 and move up and down, etc. Okay? And I can have this at 35, 55, 15. But that makes things difficult to work out. That's actually what it does look like. And that takes, remember it says, or we'll work out the time in a minute, but remember it says it takes the question says it takes 4 seconds to move from the bottom of its motion, 15 centimetres above the floor, to the top of the motion. So it takes 4 seconds to go from 15 to 55, okay? So if it takes 4 seconds to go from 15 to 55, takes 4 seconds up, then the actual whole thing, because you're going from the, that means that from there to there is 4 seconds, so therefore from there to there is 2 seconds. So we go 2 up, 2 down, 2 down, 2 up. The whole thing takes 8 seconds, okay? Because from there to there takes 4 seconds. So from there to there is 2, there to there is 2. So from there to there is 2. So 2 seconds up, 2 seconds, another 2, and another 2, because it's 2, 2, 2, 2, 8 seconds. Now, I could draw it like that, but it's really hard to see things easily. I know half of my halfway motion is here, it's 4 seconds. The top there is 2 seconds. The bottom here is 6 seconds. Now, I can draw it like that if I want, but I prefer not to. Now, it is easier to choose the origin. So even though this is at 35 centimetres, if you choose that to be 0 and you're going up 20 and down 20 from the origin, this bit really is your 55 centimetre and this bit really is your 15 centimetre. But I'm just going to have those written on the side. But if I just look at the motion of the particle, because from the centre it goes 20 up and 20 down, and it takes 8 seconds to complete. So it is easier to choose the origin as the centre of the motion. Now the origin happens to be 35 centimetres above the ground. Also, you should choose the origin you should choose the origin as well. You should get the particle starting from the middle as well at the origin. It's best to do that as well, instead of having it shifted sideways. So I would start it at the origin, and we're going to make it a sine curve in this case. Okay, so we're going to make it a sine curve. All right, so I'm starting from the origin. So also choose the origin of time at the instant it passes through the centre. So it doesn't matter where you start it, but it is easy, this one, with a sine curve, or you could have done a cos curve if you wanted. Okay, now, we know that the period, time from beginning to end, of one complete oscillation is 8. Okay, so we know that the amplitude is 20. We know that the period is 4 lots of 2 seconds, which is 8 seconds, okay? Because it takes 4 seconds from there to there, therefore 4 seconds back down. So it's 2 lots of 4 seconds, I suppose, which is 8 seconds. Now we know that period, so what we're going to say is our equation, if we look at that equation, that's not shifted up or down. That's just a sine curve. So my general equation is x equals a sine nt. There is no plus alpha, because it's not shifted sideways at all. So what I want to do is work out what the amplitude is, and it would be 20, and the period. Now I know the period is 8 seconds. So we know that period equals 2 pi on n. So I set up this and I say 8 equals 2 pi on n. So therefore n is 2 pi on 8, which is pi on 4. So therefore my equation becomes x equals 20 sine nt, which is 20 sine pi on 4t. Okay, now with this question, they should guide you in the HSC as to what type of curve they want you to use. Sine curve is easy because it starts at the origin. Cos curve would have been okay as well, but that would have started up there and gone like that, okay? So I've decided to use a sine curve, so let's just go with that. And it's what's really good about having the centre of motion at the origin is that you don't have to go plus b. And it's also good to start your time at the origin because you don't have a plus alpha shift. So really, you've got to go for the most basic type of equation that you can do, okay? All right, now, so that's our equation. That's really important to be able to get your equation. Now, the first part of the question is, find where the particle is 3 seconds after rising through the centre of motion. So find where it is 3 seconds after rising through the centre of motion. Now, because we've made the centre of motion 0, we just want it, and we've started time at 0, we're basically looking for time is 3 seconds on this graph, which would be about here. And we're expecting the height to be, I think, somewhere between 0 and 20, but I think it's bigger than 10. Okay, so at 3 seconds, we're expecting a height bigger than 10. Okay, so what we do when t is 3, we just substitute it into this equation here. So when t is 3, x is 20 sine pi on 4 times 3. So it's sine of 3/4 pi. Now, you can just do it on your calculator as well, but 3/4 pi is quadrant 2, and sine is positive in quadrant 2, so that's 3/4 pi. And it's the same as sine pi on 4, which is sine 45, which is 1 on root 2. So it's 20 times 1 on root 2. 3 pi on 4 is there. It's the same as sine pi on 4, which is sine 45, which is 1 on root 2. So you get 20 over root 2. Now, if you rationalise that and times it by root 2 over root 2, you get 20 root 2 on 2, which is 10 root 2. Okay, so you get 20 root 2 on 2, which is 10 root 2. So therefore, the weight is, so you've got to be careful, because remember, with your graph, that position 0 is actually 35 centimetres above the ground. So therefore, the weight is the 35 centimetres plus another 10 root 2 centimetres above the ground. So please don't forget to do that step, okay? Now, for the next question, part B. Part B says to find the speed at the centre of motion. Now, we know the centre of motion here is occurring when x is 0, but there are a few ways you can do this question. We also know that at the centre of motion, that the particle moves the fastest at the centre of motion. The other thing we can do is just differentiate the equation. So we've got that x equals 20 sine pi on 4t. So therefore, velocity is the derivative of that, which will be, sorry, that's a pi. So we've got x equals 20 sine pi on 4t. So velocity is 20 times, we need to differentiate sine pi on 4t, and we get pi on 4 cos. So we get cos pi on 4t times pi on 4, and that gives us 20 times pi on 4 is 5 pi cos pi on 4t. Now, that means that the velocity equation has an amplitude of 5 pi. That 5 pi is actually the maximum velocity, or the speed at the centre. So, So at the weight, or the actual weight, is at the centre when t is 0, according to our equation. And so therefore, now the reason it's that is that when we drew the initial curve, remember this is our original curve for x, 0, 8 seconds, 4 seconds. At time 0, we've drawn our curve such that the weight is at the centre. The weight is at x is 0 when t is 0. So therefore the velocity is 5 pi times, now our equation for velocity is 5 pi. We know that velocity is 5 pi cos pi on 4t. That's our equation for velocity. So when we substitute time is 0 into that, we get 5 pi cos 0, which is cos of 0 is 1. So we get 5 pi centimetres per second. But you can actually, by just knowing what the velocity equation is, the maximum velocity is the amplitude of 5 pi. And the maximum velocity always occurs in the centre of motion. Okay? All right. Now, I think that there was another way that you could do that question. Okay, the last part of the question is to find the maximum acceleration. Now, you've got to remember with your particle, acceleration 0 in the middle. Remember, simple harmonic motion, acceleration is always acting towards the centre of motion. So I'm going to draw a little diagram here. So, acceleration, here is my particle. It goes, acceleration is up and down. So here the acceleration is negative and there the acceleration is positive. Now, acceleration will be, and in the middle, acceleration is 0 in the centre of motion. So the maximum acceleration would be down here when x is 15, because from our original graph we've got 15 and we've got 55. But on my sine curve that I've got, remember, we're not drawing the centre to be, sorry, not 0, that's 35, but acceleration is 0 in the middle. On our curve, we haven't, 15 is not 15, it's actually the negative 20. So the maximum acceleration will occur when the particle is at the very bottom of its motion, so it should be down here, should occur there. But what I'm going to do, you can interpret it from the graph. So or if you want, you can differentiate to get the maximum acceleration. So we know that velocity is, if we look back up here, velocity is 5 pi cos pi on 4t, okay? If we differentiate that, if you differentiate cos, you get negative sine. So we get 5 pi times negative sine pi on 4t times pi on 4. And we get negative 5 pi squared on 4 sine pi t on 4. So if I just look at that, the maximum acceleration will be 5 pi squared on 4. Look, that's probably the easiest way to do it, just by looking at the amplitude of the acceleration curve. So the maximum will be 5 pi squared on 4, the minimum will be negative 5 pi squared on 4, meaning that the maximum's acting upwards and the minimum is actually acting downwards. Now, if you don't want to do it that way, you don't have to, but it is the easiest way to do it. The other way you can do it is, or you can say acceleration is maximum. See, that is the easiest way, just looking at the amplitude. But you can say acceleration is maximum when particle is at the bottom. Particle is at the bottom of its motion, because we know acceleration acts towards the centre. Now, according to this, it's when x is 15, but remember, we're using this graph here, so that will be when x is negative 20. So you can find the time when x is negative 20 if you want. So we can go negative 20 is equal to, what's the graph? So it will be when x is negative 20. That's when it's accelerating the quickest in the positive direction, or with the most force, I suppose. So dividing by 20, we get negative 1 equals sine pi on 4t. So you've got to look at quadrants there. When is sine negative, we've got quadrants 2 and 3, and acute angle pi and 4t. So this is a lot longer. Acute angle pi and 4t. Actually, no, we don't do acute angles with that. We just draw the sine curve. Easier, because it's 1. Whenever you're doing sine of something is 0, 1, or negative 1, you just draw the graph. So sine of what is negative 1, and it's 3 pi and 2. So therefore pi on 4t equals 3 pi and 2, because that's 2 pi. So therefore t is 3 pi on 2 divided by pi on 4, or times 4 on pi, which is 6 seconds. Now, if you look at, so it'll occur when time is 6 seconds. If you look at the original graph that I had, that was the case anyway. We said acceleration is maximum when the particle's coming back up, because acceleration acts towards the centre. So we can see that the bottom point is there. So that is halfway between 4 and 8, which is at 6 seconds. So you could just use the graph to say acceleration's maximum down here, and that when t equals 6, you can work out what x is. Actually, we've got that. What do we want? Oh, sorry, yes. Then you can say when t equals 6, you can substitute it into the acceleration equation. Acceleration is negative 5 pi squared on 4 times sine pi on 4 times 6, which is negative 5 pi squared on 4 times sine of 3 pi on 2. Now we know that the sine of 3 pi on 2 is negative 1. So it's negative 5 pi squared on 4 times negative 1, which is 5 pi squared on 4. And the units will be, I think it's centimetres per second squared. Okay, now look, we got that answer up here, which is so much easier. So to know that your maximum amplitude, the maximum acceleration will be the same as the amplitude of the acceleration curve is a much easier way to do. The negative will be when it's acting in the negative direction. So that 5 pi squared on 4, the negative one occurs up here, and the 5 pi squared on 4 acceleration going upwards occurs down there. Okay? So that's the end of that question.